Hello, this is Dr. Hanaa Assil, and this is a video discussing the questions or some questions on the chapter on qualitative analysis in IGCSE Chemistry. This is mainly the Cambridge syllabus. It could apply also some of it to the Excel. Now, one type of question will be the multiple choice questions. Remember, in order to answer any questions on the qualitative analysis, which are the tests for cations and anions and gases, you need to memorize the tests. So please make sure that these tests are memorized before you do the questions, or I hope this will help you to memorize it if it's difficult for you. So the first question says aqueous sodium hydroxide is added to two different solutions with the results shown. One of them gave him green precipitate, the other one gave light blue precipitate, and he's asking what is X and what is Y. Now we're going to try and remember which one gives green precipitate with sodium hydroxide. Well, you should remember that the one that gives green precipitate with sodium hydroxide is iron 2, not any of these other options. Now, which one gives blue precipitate? This blue precipitate is obtained with copper 2, so my result would be iron 2 and copper 2. So the next question says, a mixture containing two anions was tested and the results are shown below. Dilute nitric acid was added and it gave effervescence of a gas which turned lime water milky. Now the question is, which one has a test that in which you add acid and it gives a gas that turns lime water milky? You should realize that this test is for carbonates, because when you add acid to carbonates, it gives carbon dioxide gas. So that first test indicates that we have carbonates. Now the next test says dilute nitric acid and silver nitrate gave yellow precipitate. Now you ask yourself, silver nitrate is a test for what? It's a test for chloride or bromide or iodide. And you should remember that with chloride, it gives white precipitate. With bromide, it gives cream precipitate. Now, which one gives yellow? It is the iodide. That means I have carbonate and iodide. The next question says compound X is tested and these are the results. Aqueous sodium hydroxide is added, then heated gently, gas given off, which turns damp red litmus paper to blue. Now, this is a test for what? When I add sodium hydroxide and I heat and it gives a gas that turns damp red litmus paper to blue, this is test for ammonium ions, because when we add sodium hydroxide to an ammonium ion, it gives off ammonia gas, which turns damp red litmus paper to blue. So that first test indicates that we have ammonium. Then hydrochloric acid is added and it gives effervescence gas given off, which turns lime water milky. Again, when we say we add acid and it gives a gas that turns lime water milky, that was test for carbonates. So we should have ammonium and carbonate. So the next question says the results of 3 tests on a solution of compound X are shown. He first added sodium hydroxide and he got white precipitate soluble in excess. And then he added aqueous ammonia. Again, he got a white precipitate soluble in excess. We said when we say white precipitate soluble in excess, that means when I add drops, it gives a precipitate, a white cloud. And then once I add more and more of the sodium hydroxide or the ammonia in this case, the precipitate dissolves. That means it disappears and we have a colorless solution. Now, which ion gives white precipitate soluble in excess with both sodium hydroxide and ammonia? You should realize that that is zinc. Then he said dilute hydrochloric acid gives bubbles of gas. Again, when we add acid and gives bubbles of gas that turn lime water milky, that is a test for carbonate. This next question deals with the flame test. So he's saying when sodium is burnt in oxygen, what color is the flame? Remember, a flame test is test for these kinds of ions, lithium, sodium, potassium, copper. Each of them give a specific color in the flame. So when we're saying sodium, can you see which one we should get with sodium? It should be yellow. The next question says which aqueous ion causes a yellow precipitate to form when acidified aqueous lead nitrate is added to it? Again, we said lead nitrate or silver nitrate is test for what? It's test for chloride, bromide, iodide. Whether we're saying lead nitrate or silver nitrate, they give the same results. So which one gives a yellow precipitate? You should realize that the chloride gives white, the bromide gives cream precipitate, and the iodide is the one that gives a yellow precipitate. So that means that we have iodide. Here the question says some barium iodide is dissolved in water. Aqueous lead nitrate is added to the solution until no more precipitate forms. This precipitate is filtered off. Now let's take a look at this. He has barium iodide. What did he add? He added lead nitrate. Again, lead nitrate is test for what? You should remember again. Lead nitrate is test for chloride, bromide, iodide, just like silver nitrate. Now, which one do I have? Chloride or bromide or iodide? Well, he has barium iodide. So when he adds lead nitrate, which color of precipitate should he get? If it is iodide, he should get yellow. So my answer is C or D. Now, after that, he added dilute sulfuric acid to the barium solution that we have. Barium chloride or barium nitrate or barium solution in general is used to test for sulfate. If I add barium ions to something that has sulfate like sulfuric acid, I will end up with a white precipitate, and that means that second precipitate that we get is white, and that means the answer is C. The next question says two tests are carried out on a solution containing copper sulfate and sodium chloride. And he said the first test he added barium chloride. The first thing I'm going to ask myself, barium chloride is test for what? Barium chloride is test for sulfate. Well, do we have sulfate? Yes, he says I have copper sulfate. So if I add barium chloride to something that has sulfate, what should we get? Actually, we should get a white precipitate, not a blue. So that test number 1 is not a correct test. If he adds barium chloride to that solution, he has sulfate, so he will end up with a white precipitate, not a blue. Then he added silver nitrate. Again, silver nitrate is test for what? We said it is test for chloride, bromide, iodide. Now, which one do we have? We have chloride, so I should get a white precipitate, so that test 2 is correct, and that means my answer is C. I hope this is getting easier to answer and easier to think about. Okay, aqueous solution S is added to aqueous ammonium chloride. The mixture is heated, ammonia gas is given off. Now, what do we add to something that has ammonium and gives ammonia gas? Remember, the test for ammonium was I should add sodium hydroxide. If I add sodium hydroxide to ammonium something, it should give bubbles of ammonia gas that turn damp red litmus paper to blue. So that is my solution that I added to the ammonia. Okay, the next question says, which two compounds give a white precipitate when their aqueous solutions are mixed? Well, let's look at A. A says silver nitrate and sodium chloride. Again, silver nitrate is a test for chloride, bromide, iodide. If I add it to chloride, what do I get? Silver nitrate and chloride will give a white precipitate. But if we look at B, it says with iodide, no, iodide would give a yellow. And he's telling me which of these will give a white precipitate. So actually my answer is A. If we look at C, for example, sodium hydroxide and copper 2, you should remember that sodium hydroxide and copper 2 gives blue precipitate. Sodium hydroxide and iron 2 gives green precipitate. So the only one that would give a white precipitate is silver nitrate and sodium chloride. Then this next question says aqueous sodium hydroxide is added to solid X and the mixture is heated. A green precipitate is formed and an alkaline gas is given off. First of all, which one gives a green precipitate when we add sodium hydroxide? You should remember that this is iron 2 or Fe2 plus. So if we add sodium hydroxide to something and it gives green precipitate, then we have Fe2 plus or iron 2. Then he says when he added the sodium hydroxide and the mixture is heated, he got an alkaline gas. Remember, this is a test for what? This is a test for ammonium. When I add sodium hydroxide and heat it, it should give me a gas that turns damp red litmus paper to blue, which is ammonia. So the mixture that I have here is actually a mixture of ammonium and iron 2 or Fe2 plus. This question says aqueous sodium hydroxide and aqueous ammonia each give a white precipitate when added to zinc. Now what happens to the precipitate? If you remember, zinc is something that will give a white precipitate that dissolves in excess to give a colorless solution in both cases, whether I'm adding excess sodium hydroxide or I'm adding excess ammonia. So remember that zinc is the only one that would give a white precipitate that dissolves in both, in excess sodium hydroxide and excess ammonia to give a colorless solution. The next question says the results of 2 tests are shown. He put aqueous sodium hydroxide and gave him green precipitate. Again, which one gives green precipitate when we add sodium hydroxide? We said that is iron 2. Then he added silver nitrate and he got yellow. Again, silver nitrate is test for chloride, bromide, iodide. Now, which one gives yellow? The iodide. So that means that I have iron 2 iodide. Following? Okay. Then this next part of the questions are questions from either paper 3 or paper 6 or actually paper 4 if this is the O-level stage, because they all have the same syllabus. Now, a precipitate may be formed when 2 aqueous solutions are mixed. The color of these precipitates may be used to identify ions. So he's telling me what is the solution that I should add to test for each of these ions. He already tells me that it should give a precipitate. He just wants the color of the precipitate. Again, iron 2. How do we test for iron 2? Remember, I either add aqueous sodium hydroxide or I add aqueous ammonia. In both cases, what color of precipitate do we get with iron 2? We get green precipitate with iron 2. Now, iodide. What was the solution used to test for iodide? It is dilute nitric acid and silver nitrate or lead nitrate. So it can be dilute nitric acid and lead nitrate or dilute nitric acid and silver nitrate. And they both give the same result. What do we get with iodide? Again, remember, iodide is the only thing that gives yellow. So I get a yellow precipitate. Chloride. The test for chloride is the same as that for iodide. Remember that nitric acid and silver nitrate are test for chloride or bromide or iodide. But with chloride, which precipitate do we get? We get white precipitate. Now, how do we test for sulfate? Sulfate, I need to add dilute hydrochloric acid and aqueous barium chloride, or I could use nitric acid and barium nitrate. So either both of them are chlorides or both of them are nitrates. So nitric acid and barium nitrate or hydrochloric acid and barium chloride. The barium ions react with the sulfate. Which precipitate do we get? We get a white precipitate. Please learn all the tests. Now, these next questions are questions that are direct to write the test. So he says, describe a test for something. So you just write the test and what you should get. Describe a test for calcium ions. So for calcium ions, we have add aqueous sodium hydroxide. Now, what should I get if I have calcium? I should have a white precipitate insoluble in excess. Again, we said, what does that mean? It means if I add drops of sodium hydroxide, we get a white precipitate. Now continue to add sodium hydroxide so that the sodium hydroxide is now excess. For in case of calcium, the precipitate will still remain. So we say it is insoluble in excess. Test for copper 2. What was the test for copper 2? We can also add aqueous sodium hydroxide. In this case, what do we get? We get a light blue precipitate insoluble in excess. So the light blue precipitate remains. Describe a test for hydrogen. What was the test for hydrogen? The test for hydrogen was insert a lighted splint. Remember that we can either use a lighted splint or a glowing splint. For hydrogen, we use a lighted splint. If we use a lighted splint on hydrogen, it pops. For oxygen, we use a glowing splint. Describe a test for chlorine. Again, I'm going to remind you, we have a test for chloride ions. That means something chloride, sodium chloride, potassium, whatever. And a test for chlorine, which is usually chlorine gas. And it is the same test even if we dissolve the chlorine gas in water. So chlorine, we say insert damp litmus paper. It bleaches. Bleaches means when we have the gas and we put damp litmus paper, the litmus paper the color will be removed completely. It will become white, but we don't say it becomes white. We say it bleaches. So it's neither blue nor red. It turns white. Then this is another type of questions where he says, describe a test you can distinguish between something. So we have here two things. I need to use a test to distinguish between them. That means I need to choose one test. So I have to tell him do something that will give different results with both, or will react with one and not the other. So what are we distinguishing between? We're distinguishing between ethene and methane. So you should know, if you have not done organic, ethene is an alkene. Alkenes have C double bond C. They have a double bond between the carbons. Now, to distinguish between them, what we do is we add bromine water. Bromine water will react only with an alkene. And when we add it with an alkene, it turns from reddish brown to colorless. So the original color of bromine water is reddish brown, or we refer to it as orange. But when we add it to something that is an alkene, ethene, propene, butene, anything that has ene at the end, the reddish brown color disappears, or the reddish brown color becomes colorless. If you add it to anything else, for example with methane, there is no change. Describe a test for ammonia gas. Again, there is test for ammonia gas and there is test for ammonium ions. Remember that ammonia gas, you just insert damp red litmus paper, it turns to blue. But if we were doing test for ammonium, you have to add sodium hydroxide first, heat, and then it brings out ammonia that turns damp red litmus paper to blue. Okay, describe a test for iron 3. Again, add aqueous sodium hydroxide. With iron 3, what do we get? With iron 3, we get a reddish brown precipitate. With iron 3, we get a reddish brown precipitate. Describe a test for aluminium ions. Now, add aqueous sodium hydroxide. With aluminium ions, I get a white precipitate soluble in excess, giving a colorless solution. That means you add drops of sodium hydroxide to something that has aluminium ions. You get first a white precipitate, and then as you add more and more sodium hydroxide, the precipitate disappears and we get a colorless solution. So we say white precipitate soluble in excess, giving a colorless solution. Describe a test for chromium ions. Again, add aqueous sodium hydroxide. With chromium ions, we get a green precipitate. But remember, this one for chromium, the green precipitate dissolves. Green precipitate soluble in excess. For iron 2, remember we said we also get a green precipitate with iron 2, but for iron 2, the green precipitate is insoluble in excess. It will remain. For chromium, it will disappear and form a green solution. Describe a test for iodide. Again, we said any halide, chloride, bromide, iodide. The test is nitric acid and silver nitrate or nitric acid and lead nitrate. Now, iodide gives the yellow precipitate. Remember, we said chloride, bromide, iodide. Chloride gives white, bromide gives cream precipitate, iodide gives yellow. Describe a test for carbon dioxide gas. Again, how do we test for carbon dioxide gas? We said bubble the gas through lime water. The lime water will turn milky. Now, this is a test for sulfate. What was the test for sulfate? We said the test for sulfate is add dilute nitric acid and aqueous barium nitrate, or we said hydrochloric acid and barium chloride. If we have sulfate, what do we get? We get a white precipitate. Remember, by the way, that you have to write the word precipitate out. You don't write any short form of the word precipitate. So you need to learn the spelling. This next question says, describe a test for nitrate ions. What was the test for nitrate ions? Remember, add aqueous sodium hydroxide, then aluminium foil and warm gently. What should we get? Bubbles of gas are formed that turn damp red litmus paper to blue. So we add sodium hydroxide and aluminium foil. Remember, this is the only test that needs to add aluminium foil to it. Aqueous sodium hydroxide, aluminium foil, and warm gently. Now, the bubbles of gas produced turn damp red litmus paper to blue because we said in this case it gives out ammonia gas. So the name of this gas is ammonia. Okay, here he's saying describe a test for chloride ions. Again, what was the test for chloride ions? Dilute nitric acid and silver nitrate or lead nitrate, we said. With chloride, what should I get? I should get a white precipitate. Then this question, bromine water can be used to distinguish between ethane and ethene. Again, we said ethene is an alkene that has a double bond. Describe what you would observe when bromine water is added to ethene. We said bromine water originally is reddish brown or orange. If you add ethene to it, that's an alkene, it becomes colorless. So it turns from reddish brown to color. Describe what you would observe when aqueous sodium hydroxide is added to a solution containing aluminium ions. Okay, let's see. What was the test for aluminium? When we add sodium hydroxide, what happens? White precipitate, soluble in excess, giving a colorless solution. That is the result of aluminium ions with sodium hydroxide. Then the next question says lead bromide is formed as a precipitate when aqueous solutions of lead nitrate and potassium bromide are mixed. What do you understand by the term precipitate? Remember, what do we mean by precipitate? Precipitate is a solid formed from the reaction of two solutions. So I add two solutions together and I start to get cloudiness or some sort of solid forming. This solid is called a precipitate. A solution of a metal salt reacts with aqueous sodium hydroxide to form a white precipitate. The white precipitate is soluble in excess. We said which of these choices would give, with sodium hydroxide, white precipitate soluble in excess. Remember, the calcium would give white precipitate, but the white precipitate is insoluble. Copper 2, of course, will give what? Blue precipitate. Iron 2 will give green precipitate. It is the zinc that will give white precipitate soluble in excess. Now, if you add zinc something to sodium hydroxide, what should it give you? What would be the name of that white precipitate? It is zinc hydroxide. Okay, so the precipitate that we have forming is zinc hydroxide. When we add zinc ions to sodium hydroxide, we said this is white precipitate soluble in excess, giving colorless solution. This question says, when the air is drawn through the apparatus, the lime water, can you see the U tube that has lime water in it? He says the lime water turns milky. Which gas turns lime water milky? You should know carbon dioxide is the gas that would turn lime water milky. Then he says he has white anhydrous copper sulfate turns to blue. Remember, this was test for what? When I add something to anhydrous copper sulfate, it turns from white to blue. Well, that was the test for what? When copper 2 chloride is heated strongly, a gas is given off. Now, he's telling me the gas is green in color and bleaches litmus paper. Remember that the gas that is green in color and bleaches litmus paper is chlorine. Okay? Describe what you would observe when a few drops of silver nitrate solution is added to hydrochloric acid. Well, let's see. Silver nitrate is test for what? It's test for chloride, bromide, iodide. Now, hydrochloric acid has which of these? It has chloride, so it should give white precipitate, because this is what we get when silver nitrate reacts with something that has chloride. Hydrochloric acid is an acid that has chloride. Now he's saying aqueous sodium hydroxide or aqueous ammonia can be used to test for calcium ions. Describe the results of these. Calcium with sodium hydroxide, what should you get? Calcium with sodium hydroxide, you should get white precipitate insoluble in excess. What about with aqueous ammonia? I should get no precipitate or very slight white precipitate. You tell him all of that. So don't just say no precipitate. Actually, if I have calcium with aqueous ammonia, I either don't get any precipitate or a very slight white precipitate. This question again says, state the name of the substance that turned the white copper sulfate to blue. Again, which substance turns white copper sulfate to blue? Remember, that was the chemical test for what? How could you change the blue copper sulfate back to white? Now, the blue copper sulfate is something that is hydrated. It has water of crystallization in it. So to return it to the white, which is the anhydrous, I need to heat it to get rid of the water. This question says, choose from the list. Each compound can be used once or more than once, not at all, and so on. Which compound is an alkaline gas? Remember that the only alkaline gas that we deal with is ammonia. Ammonia is an alkaline gas. It turns red litmus to blue. The other gases are either acidic or neutral. So carbon dioxide is acidic. Sulfur dioxide is acidic. Gases like hydrogen, oxygen are neutral. Carbon monoxide is neutral. So the only alkaline gas is ammonia. Okay, which one turns blue cobalt chloride paper to pink? Again, turning blue cobalt chloride paper to pink was test for what? It was actually the chemical test for water. Which one reacts with an acid to give carbon dioxide? Well, this is a question about acids and bases. Remember that the one that would react with acid to give carbon dioxide gas is a carbonate. So this one is calcium carbonate. Now, which gives a light blue precipitate with aqueous sodium hydroxide? Remember, the only one that gives blue is copper something. So this is the copper sulfate. Now, this is another kind of questions which are usually present at the end of paper 6 in the Cambridge syllabus, or in the middle of the papers if it is in edX. Solid E was analyzed and he gives me some sort of information. So here he's saying E is an aluminium salt. So we have to keep in mind that we're talking about something that has aluminium ions. Now, appearance of solid E, white crystalline solid. Remember, when he says appearance of something, it is either a white solid, colorless solution, or something that is colored. Now, if it is something that is colored, you have to remember that it is something that has transition matter. But if it is colorless, as a solid, we refer to it as white. As a solution, we refer to it as colorless solution. So the fact that he's telling me that this is a white solid just tells me that there is no transition matter. Then he says a little of solid E was heated in a test tube. Colorless drops of liquid formed at the top of the tube. Remember, if he says that he heated the solid and he got colorless liquids, colorless drops of liquid at the top of the tube, that just tells me that this solid was a hydrated salt. So it means that the solid originally had water of crystallization, or it had water in the crystal. So when I heated it, this water came out. Then he says a little of solid E was dissolved in distilled water. The solution was divided into 4 test tubes, and he did the following tests. Now, the test 2 says he added drops of aqueous sodium hydroxide. So the first thing I'm going to ask myself, he added the sodium hydroxide to what? What do we have? At the top, he says E was an aluminium salt. So we're adding sodium hydroxide to something that has aluminium. We're adding drops at the beginning. When I add drops of sodium hydroxide to something that has aluminium, I'll get a white precipitate. But then when I add excess, remember we say white precipitate soluble in excess, giving a colorless solution. So your observation here would be the precipitate dissolves, it gives a colorless solution. Then test 3 says drops of aqueous ammonia were added to the second test tube. Again, he's adding aqueous ammonia to what? He's adding it to something that has aluminium. So what happens if I add aqueous ammonia? I get white precipitate insoluble in excess. 2 further tests are carried out. So he has test 4 to the third test tube. Dilute hydrochloric acid was added, followed by barium nitrate. The first thing I ask myself, barium nitrate is test for what? Well, it's test for sulfate. Now, if I have sulfate, what am I supposed to get? I'm supposed to get a white precipitate. Now, when he did it, he got no reaction. What does that tell you? That tells you that there is no sulfate. Then test 5 says to the fourth test tube, he added aqueous sodium hydroxide, aluminium foil, the mixture was warmed, he got effervescence, pungent gas given off, and the gas turned damp red litmus paper to blue. This is test for what? Well, if I add sodium hydroxide and aluminium foil and I get a gas that turns damp red litmus paper to blue, this is test for nitrate, and the gas that comes out is ammonia gas. Okay, so what does test 1 tell you about the solid? If we go back to test 1, you'll find that that is the test where he said he heated the solid and it gave drops of a liquid at the top of the tube. That means that it is a hydrated salt. And then he says identify the gas given off in test 5. That test 5 was the one where we were testing for nitrate and it gave out ammonia gas. Now, what conclusions could we draw about the solid? What did we find about it? We found that it has no sulfate and that it has nitrate ion. Okay, the next question is talking about distinguishing again between 2 things. And remember we said if we're distinguishing between 2 things, we should do one test either that works with one and not the other, or works with one and gives a different result with the other. So if I'm trying to distinguish between water and ethanol, in this case, I can either do the test for water or do the test for ethanol. So if I add anhydrous copper sulfate, this is test for which one? This is test for water. Remember, when I add anhydrous copper sulfate, if it is water, it turns from white to blue. But of course, with ethanol, there will be no effect. I could also have said the test for ethanol. The test for ethanol that we have is bring a lighted splint near the liquid. If it is ethanol, the liquid will catch fire. And of course, with water, there is no effect. So either the test for water or the test for ethanol. Now, the next one is asking to distinguish between sulfuric acid and sodium sulfate. First of all, we cannot do the test for sulfate, because if we do the test for sulfate, both of them will give the same results. So the difference between sulfuric acid and sodium sulfate is that one of it is an acid. So I can do the test for acid, and remember that the test for acid is we add carbonate, then it gives carbon dioxide gas. Or I can do the test for sodium. So either I say add sodium carbonate with acid, it gives bubbles of gas that turn lime water milky, and with sodium sulfate, no effect. Or I could have told him do the flame test with sulfuric acid, no effect. With sodium, do you remember the flame test for sodium? It should give a yellow flame. Here we're talking about distinguishing between hydrochloric acid and nitric acid. So now I cannot add carbonate, because carbonate with both of them will give bubbles of gas that turn lime water milky. So the difference between hydrochloric acid and nitric acid is that one of them has chloride and the other has nitrate. So either I do the test for chloride, so it will work with the hydrochloric and not the other one, or I do the test for nitrate, then it will work with the nitric and not with hydrochloric. So I can say, for example, add dilute nitric acid and aqueous silver nitrate. Now this is test for which one? You should remember that this is test for chloride. So the acid that has chloride will give me white precipitate. The acid that does not have chloride will have no effect. Copper sulfate and copper carbonate. Again, both of them have copper. So I cannot do the test for copper. Both of them would give me the same result. But the difference here is one of them is a sulfate and the other is a carbonate. So either I do the test for sulfate or I do the test for carbonate. So if I say add dilute hydrochloric acid, now with the sulfate, I will not see anything. So no effect or no change. With the carbonate, we get bubbles of gas that turn lime water milky. Do you get the idea? Okay. Now, this kind of question again, he says a solid D, which is a soluble metal sulfate. So he's telling me that I have sulfate. Appearance of the solid, he says it's pale green crystals. Again, what does that tell you? When we say it is colored, that means that it has a transition metal in it. So we expect to find a transition metal. Now, solid D was heated in a test tube. Condensation formed at the top of the test tube. Again, when I heat the test tube with the solid and I get condensation formed at the top of the test tube, we said this means it is a hydrated salt or it has water of crystallization. Then he did tests on the aqueous solution. So you should realize that the aqueous solution is the metal sulfate that we're talking about. So several drops of aqueous sodium hydroxide were added and he got a green precipitate. And when he did excess, the green precipitate remained. When he added excess aqueous ammonia, he also got a green precipitate. Now, which one gives a green precipitate insoluble in excess with both? It's iron 2. So that means that I have iron 2. Then he said aqueous silver nitrate and dilute nitric acid was added to the third portion. Remember, he said I have a metal sulfate. And you see the first line, a solid D, which is a soluble metal sulfate. So now he's adding silver nitrate. Silver nitrate is test for what? Silver nitrate is test for chloride, bromide, iodide. Do I have any of that? No. So my result is no effect or no change. Then he's adding aqueous barium nitrate and dilute nitric acid. Again, barium nitrate is test for what? Barium nitrate is test for sulfate. When I added, I have sulfate, so I should get white precipitate. Again, what does test A tell you about the solid? Remember that we said test A said it is colored, and we said that means it has transition metal, and it gave condensation at the top of the tube, and we said that means it is a hydrated solid. What conclusions can you draw about the identity of solid D? Well, we found that it is hydrated and it has iron 2. Remember, the word iron alone has 1 mark, and the fact that you're identifying that it is iron 2, not iron 3, that's another mark, plus the hydrated, that's how you get the 3 marks. So please, when you write iron, remember to say whether it is iron 2 or iron 3. The next question says we have two liquids, L and M. L, he's saying, is potassium iodide, and M is a colorless liquid. So what do you think would be the appearance of liquid L? First of all, this is a liquid. Now, the question you're going to ask yourself, does it have a transition metal? Well, he's saying L is potassium iodide. There is no transition metal. So this should be a colorless solution. If it were a solid, I would say white. So if it is a solid, we say white if it doesn't have transition metal. If it's a solution, we say colorless since it has no transition metal. Then he said liquid L was divided into 3 equal portions. An iodine crystal was added to the first portion. The test tube was stoppered and the contents changed and shaken, and he said the liquid turned orange. This just tells me that the iodine dissolved in the potassium iodide, because L is potassium iodide. He added to it iodine, while the iodine dissolved in the potassium iodide solution. Then he added an equal volume of liquid M to the test tube, the contents shaken and left to stand, and he found that it gives 2 layers. Now, if I add something to an aqueous solution, you know what an aqueous solution means. An aqueous solution means something dissolved in water. So that means that I'm adding a liquid to something dissolved in water. If it gives 2 layers, that just tells me that that liquid is an organic compound or an organic solvent, because organic solvents will not mix with water or with an aqueous solution. To the second portion of liquid L, he added dilute nitric acid and barium nitrate. Again, I go back. L was what? L was potassium iodide. Now he's adding barium nitrate. Again, barium nitrate is test for what? It's test for sulfate. Do I have sulfate? No, I don't. I have potassium iodide. I don't have sulfate. So when I add barium nitrate, it is no effect or no change. To the third portion of L, dilute nitric acid and silver nitrate. Again, silver nitrate is test for chloride, bromide, iodide. Now, which one do I have? He said I have iodide. Iodide would give a yellow precipitate. What does the color of liquid L? Why does the color of liquid L change in test B? Again, we said this is because the iodine dissolves in solution L. What conclusions can you draw from the test? We said that if it does not mix, then M is an organic liquid that is not miscible with solution L. The next question says, a mixture of 2 solids, M and N, was analyzed. Solid M was zinc sulfate. So keep in mind, M is zinc sulfate and it is water soluble. So if he adds water, it would be in the filtrate. So I have zinc sulfate and a solid that I have no idea about. So he said he added distilled water to the mixture in the boiling tube and shaken. The contents of the tube were filtered, the filtrate and the residue were tested. So the tests on the filtrate was divided into 4 portions. Again, remind yourself, the filtrate is the one that has M, which is zinc sulfate. So what I have here is zinc sulfate. Now, what is he doing? He's adding drops of aqueous sodium hydroxide and then excess. We're adding that to zinc, and we said if we add that to zinc, what should we have? We should have a white precipitate, soluble in excess, giving a colorless solution. With aqueous ammonia and zinc, we get exactly the same thing, white precipitate, soluble in excess, giving a colorless solution. Okay, then he added about 1 centimeter cubed of dilute nitric acid followed by silver nitrate. Again, silver nitrate is test for what? It's test for chloride, bromide, iodide. What do we have? We have zinc sulfate, no halide. So if I add silver nitrate, no effect or no change. About 1 centimeter cubed of dilute nitric acid followed by barium nitrate. Again, barium nitrate is test for what? Barium nitrate is test for sulfate. Do I have sulfate? Yes, he said I have zinc sulfate. So what if I have sulfate, what should I get? I should get a white precipitate. Getting easier? Okay. Then he says tests on the residue. He didn't give me anything about the residue. He's still going to give me information about the residue. So he says the appearance of the residue is a black solid. Remember that black is regarded as a color. So the fact that he's saying it's a black solid means I have a transition metal. Then he says dilute hydrochloric acid was added to a little of the residue. The mixture was heated and the gas given off was tested with damp blue litmus paper. He says he had effervescence, pungent gas that bleached litmus paper. Which gas bleaches litmus paper? Do you remember? Chlorine gas. Okay, so identify the gas given off in E, that is chlorine. Then he says aqueous hydrogen peroxide was added to a little of the residue. The gas given off was tested, and he said it gave out a gas that glowing splint was relit. Which gas we will cause the glowing splint to relight? We said that is the test for oxygen. So from these results, what conclusions can you draw about solid N? First of all, it is a transition metal, or it has a transition metal. And when we added it to hydrogen peroxide, I want you to remember that we mentioned hydrogen peroxide in our syllabus in only one case, when we're adding a catalyst to it. Hydrogen peroxide is something that breaks down to give oxygen gas, but the reaction on its own is very slow. If I add anything to it, it could make the reaction faster and give out more oxygen. So the fact that I added this substance we're talking about to hydrogen peroxide and it gave out oxygen gas, that means that this acts as a catalyst. You know what's a catalyst? Catalyst means makes the reaction faster. Another question says, describe a chemical test to distinguish between aqueous chlorine and aqueous sodium chloride. Remember we said we have something called chlorine and we have a test for that, and we have chloride, a different test. So here you're trying to distinguish between them. Well, you give me the test for one, it should work with one and not for the other. So which test do we want to use? Well, let's use this one, dilute nitric acid and silver nitrate. This is test for which one? This is test for chloride. So with chlorine, it will not react, but with chloride, it will give a white precipitate. Now, the next test, we want to distinguish between iron 2 chloride and iron 3 chloride. Both of them are chloride. So I cannot use the test for chloride. But the difference between them is one is iron 2 and the other is iron 3. So I do the test that will distinguish between them. Add aqueous sodium hydroxide with iron 2. It will give a green precipitate. Iron 3, a reddish brown precipitate. Okay, let's look at this next question. It says 3 different liquids, PQ and R, were analyzed. P was an aqueous solution of sulfuric acid. If we say that P was sulfuric acid, what is the appearance of P? Remember that all acids are what? All acids are colorless solutions. And then we want to do as he said for the others. So he said Q is colorless, smell of vinegar. R is colorless, no smell. So P, sulfuric acid, would be what? Colorless and no smell. Now, what would be the pH of P? You have to remember, sulfuric acid is a strong acid. So its pH would be something like 1 or 2 or 3, not more than that. He put a piece of magnesium ribbon, was added to a little of each liquid. The gas given off by the liquid was tested. So he's adding magnesium to sulfuric acid. if you remember from the reactions of acids with metal will give a gas. Which gas? Hydrogen gas. So if I put magnesium on sulfuric acid, what I get is effervescence or bubbles of gas, and the gas is hydrogen. So he says the gas given off was tested, so I have to tell him that the lighted splint pops. But then I have to compare the P to Q and R. So Q is slow effervescence, P is a strong acid, so that means that this would be a rapid effervescence. To a little of liquid P, hydrochloric acid and barium chloride was added. Again, barium chloride is test for what? Test for sulfate. Now, sulfuric acid is something that has sulfate, so it should give a white precipitate. Now, he's telling me that liquid R was heated to boiling in a test tube, and it boiled at 100. So, which liquid boils at 100? So, that tells me that the liquid we're talking about in R must be water. So what conclusions can you draw about liquid Q? Well, let's go back just a step and see what is Q. He said Q is colorless, smell of vinegar, pH 5. Can you see that? pH 5 means that it's a weak acid and it has a smell of vinegar, so that means it's probably ethanoic acid. So this is ethanoic acid and it's a weak acid. If it has smell of vinegar, the chemical name for vinegar is ethanoic acid. And if it has pH 5, then it is a weak acid. Now identify liquid R. We said this is something that boils at 100, so it is water. This next question says two different solutions, X and Y, were analyzed, and he's telling me that X is copper sulfate solution. So what would be the appearance of solution X? You should know that copper sulfate solution is a blue solution. To a little of solution X, aqueous sodium hydroxide was added. Again, if I have copper ions, if I add sodium hydroxide, I should get a light blue precipitate. Now, to a little of solution X, aqueous ammonia was added. Now, copper ions with ammonia. If I add drop by drop, I get light blue precipitate. But when I add excess, the precipitate dissolves to give a dark blue solution. You have to remember. Now, he's telling me test on solution Y. He's saying solution Y, he tested the pH and he found that it's pH 1. What does that tell me? You should realize that pH 1 means it's a strong acid. And then he said he added a few drops of dilute hydrochloric acid and barium chloride. Again, barium chloride is test for what? It is test for sulfate. So that means that I'm talking about something that is a strong acid that has sulfate. Which strong acid has sulfate? That should be sulfuric acid. Then this question is asking about three aqueous solutions K, L, and M. He's saying L was sodium hydroxide. The tests on the solutions are shown. Solution K and L and M are all colorless liquid. Then the pHs. He says solution K is pH 10. What does pH 10 mean? You should realize that pH 10 means it's a weak base. What would be the pH of L? If he says that L is sodium hydroxide, you should realize that sodium hydroxide is a strong base, so this is pH 12. Now he's telling me that solution M has pH 2. What does pH 2 mean? It's a strong acid. So K is a weak acid and M is a strong acid. K, that's the one that we said, which one is K here? K is the one that we said has a pH of 10. Okay. Now, he added drops of solution K were added to copper sulfate solution. So he's adding K to copper and he got a pale blue precipitate that changed into a deep blue solution. Again, remind me, copper ions would do this with what? If I add what? Remember, copper ions. If we add sodium hydroxide, they give blue precipitate that remains. But if I add what back? If I add aqueous ammonia, then I get a pale blue precipitate that dissolves in excess to give a dark blue solution. So this is telling me that K is probably ammonia solution. Experiment C1 was repeated using aluminium. So he's adding the K again to aluminium ions, and he got white precipitate insoluble in excess. Well, that means it is aqueous ammonia. That is the test for aluminium. With aqueous ammonia, it gives a white precipitate insoluble in excess. Then he said he added nitric acid and silver nitrate. Well, nitric acid and silver nitrate again are tests for chloride, bromide, iodide. So that means that if I don't get any visible reaction, that means I don't have chloride, bromide, or iodide. Okay, then we go to the experiment. So we said in this, all of this tell me that I have ammonia solution and I don't have chloride, bromide, or iodide. Then he does tests on solution L, and he says experiment C1 was repeated using solution L. Now, which one was solution L? Solution L was the sodium hydroxide. So again, if I add sodium hydroxide to something that has copper, what should I get? Light blue precipitate. And then he said experiment C2. C2 was the one that we added something to aluminium ions. So now I'm going to add the sodium hydroxide to aluminium ions. Now, what do we get if I add sodium hydroxide to aluminium ions? I get a white precipitate soluble in excess, giving colorless solution. Okay? Then he's saying test on solution M. Which one was solution M? Solution M was the one that he said is something that has pH 2. So experiment C3 is the one with silver nitrate, and he got a white precipitate. So if he adds silver nitrate to M and he got a white precipitate, that means that it has chloride. So what conclusions can you make about solution K? Solution K was the one where we found that it was ammonia solution and that it has no chloride, bromide, or iodide. Now, what conclusions can you make about solution M? We found out that M is something that has pH 2 and it is something that has chloride. So that is probably hydrochloric acid. It's a strong acid since he said it has pH 2 and it has chloride. So that would be hydrochloric acid. This question is talking about salt E, and he's saying it is ammonium chloride. So what would be the appearance of the salt? Remember, this is a solid now, so he's saying the appearance of ammonium chloride would be a white solid. This is something that does not have any transition metal. Then he said using a spatula of ammonium chloride was placed in a hard glass test tube. Inside the top of the tube was suspended a piece of damp blue litmus paper next to a piece of damp red litmus paper. And he said E was heated gently. So he's heating ammonium chloride. Do you remember when we talk about ammonium chloride and we say that ammonium chloride was made from reaction of two gases together, that is ammonia and hydrochloric acid, or ammonia and the hydrogen chloride. So if I form ammonium chloride and then I heat it, I get these gases back. So what happened was the red litmus turned blue and the blue litmus turned red. And this tells me that the ammonium chloride broke up to form ammonia and hydrochloric acid. Then E was dissolved in water to make an aqueous solution. The solution was divided into 3 test tubes. So we have ammonium chloride, and he's saying I'm adding a few drops of dilute nitric acid and silver nitrate. Again, silver nitrate to something that has chloride would give a white precipitate. To the second portion was added lead nitrate. Remember that lead nitrate gives the same result as silver nitrate. Now, to the third portion of solution was added sodium hydroxide. The mixture was boiled gently. Remember, this is the test for ammonium. We have ammonium, so when he adds sodium hydroxide and he heats and the gas given off tested, we get bubbles of gas that turn damp red litmus to blue. Name the gas given off, that is ammonia. When we have ammonium and we add sodium hydroxide and heat, it gives out ammonia. Explain the observations in test B. That is the one where we said the red litmus turned to blue and the blue turned to red. So we said that is because the ammonium chloride breaks down when heated to form HCl, which is acidic, and ammonia, which is alkaline. This question says two substances, solution D and E, were analyzed. Solution D was sulfuric acid, and he's saying the pH of D. What do you think would be the pH of D? If D is sulfuric acid, we know that sulfuric acid is a strong acid, so its pH can be 1 or 2 or 3. Just write 1. Then he said a strip of magnesium ribbon was added to D. So I'm adding magnesium to sulfuric acid. Again, when we add a metal to an acid, it gives hydrogen. So it will give bubbles of gas. And he says the gas produced was tested. So this gives lighted splint pops. That is the test for hydrogen. Then he said dilute nitric acid and silver nitrate. Well, what is D? We know D up there, he says D is sulfuric acid. So silver nitrate is test for what? Chloride, bromide, iodide. Do I have any of them? No. Then my result is no effect. Dilute nitric acid and aqueous barium nitrate. Now, barium nitrate again is test for what? It's test for sulfate. Well, sulfuric acid does have sulfate, so I will get a white precipitate. Tests on solid E, he says the appearance of solid E was studied and he's telling me it's a white solid. Again, that just means that there is no transition matter. Solid E was heated gently and then more strongly, and distilled water was added to the residue, and he ended up with something that has a pH 10. Of course, pH 10 just tells you that this means that it is a weak base. Dilute hydrochloric acid was added. Again, it gave rapid effervescence. Lime water turned milky. Remember, if I add acid to something and it gives effervescence and the gas turns lime water milky, then we know that this is test for carbonate and the gas given off is carbon dioxide. He said distilled water was added to the solution, excess sodium hydroxide was added, and he found white precipitate insoluble in excess. Now, when I add sodium hydroxide, which one gives white precipitate insoluble in excess? That is calcium ion. So identify the gas produced in test 2. Test 2 was the one where he was testing for carbon dioxide gas. What conclusions can you draw about solid E? We said we found that it has calcium and it has carbonate. That means it is calcium carbonate. This question is saying I have 3 bottles of liquids. They have lost their labels. The liquids are known to be, one of them is sodium iodide, the other one is hexene, and the third is dilute nitric acid. Outline chemical tests you could use to distinguish between these liquids. Now, the first one, sodium iodide. How can I show that this is sodium iodide? I can either do the test for sodium or I do the test for iodide. So I can either say do the flame test, sodium will give a yellow flame, or I can do the test for iodide where I tell him add dilute nitric acid, silver nitrate, and it should give a yellow precipitate. Now hexene, again, hexene is an alkene. Remember what were the tests? What was the test for alkene? Add bromine water. It should turn from reddish brown to color. Testing for dilute nitric acid. Well, this is something that has acid. It has nitrate. So I can either test for acid by adding a carbonate or I can test for nitrate. So if I add aqueous sodium hydroxide, aluminium foil, warm gently, remember this is the test for nitrate, I should get bubbles of gas that turn damp red litmus paper to blue. Thank you for listening, bearing with me. I hope this was useful to you, and please keep listening to the video.